Hey guys, in our last video we talked about algebraic and geometric proofs, and we did those in the two-column format. There are other ways to also write proofs, and we're going to talk about those other ways today. As you see, they're called the flow proof and the paragraph proof. We're going to be taking notes in your workbook on page 43, so go ahead and get that out now. Alright, so in the U-try problem, in our last video, you were required to prove the vertical angle theorem. Vertical angle theorem, remember, says that these angles 1 and 3 are the same measure, and the angles 2 and 4 are the same measure. They are opposite of each other, and they are made by two lines intersecting. Okay? So we are given right now that 1 and 3 are vertical angles. Alright, so now it's our job to determine that, or to prove that the measure of angle 1 is equal to the measure of angle 3. Alright, so we have done a proof very similar to this, but let's go ahead and take a look at it. It says, since angle 1 and angle 2 are a linear pair, and angle 2 and angle 3 are a linear pair, these pair of angles are supplementary. Remember that we talked about in the last video that linear pair means that they're supplementary, meaning they add to 180 degrees. So we can use that in this proof. Alright, so that means that angle 1 plus angle 2 is 180. That's just the definition of supplementary. And angle 2 plus angle 3 equals 180 degrees. Okay, because the measure of angle 1 and the measure of angle 2 added together equal 180, and the measure of angle 2 plus the measure of angle 3 equals 180, by substitution we can say that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. It is our job to finish this out. What we need to do now is we need to subtract the measure of angle 2 from both sides. Okay, that was your subtraction property. Now we are left with that the measure of angle 1 is equal to the measure of angle 3. That's all you have to do. Alright, so now what we're going to do is take that last proof and put it in a flow proof. This kind of looks like our deductive reasoning in a way. Given P implies Q and Q implies R, we can follow this step all the way down. So we're using a little bit of the law of syllogism here, and we're using our deductive reasoning. Okay, so we're going to be using the proof that we just did. We were given that angle 1 and angle 3 are vertical angles. Notice that inside the box here, or the bubble, is my statement, and directly outside of it is my reason given. So, I know that angle 1 and angle 3 are formed by intersecting lines, which means that angle 1 and angle 2 are a linear pair, while also angle 2 and angle 3 are a linear pair. And the same reasoning is the definition of a linear pair. So this blank right here is for us to put in the reasoning definition of a linear pair. This bubble is just to remind you that something goes here. When you're creating your own proofs, you only need the bubbles for the statements. Alright, so because we know that angle 1 and angle 2 are a linear pair, we know that they also have to be supplementary. So we say angle 1 and angle 2 are supplementary. And we know this because of the linear pair theorem. We proved that in our last video. So, and then it says angle 2 and angle 3 are supplementary by the linear pair theorem. They've already filled that one in for us. Now, supplementary means that they add to 180 degrees. So the measure of angle 1 plus the measure of angle 2 equals 180. That right there is the definition of supplementary. Angles. Alright, and we can say the same about the measure of angle 2 and the measure of angle 3. They equal 180 degrees by the definition of supplementary angles. So if you take a look at this, they abbreviated definition of supplementary angles. Okay? I would actually write out the word angles here. I don't mind def of sup, but this little symbol right here can be confused with too many other things. Alright, so what that means is the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. We could put here the reasoning either to be by substitution or by the transitive property. Either one of those cases will work. If you don't remember which property I'm talking about, refer to your notes from the last video, Algebraic and Geometric Proofs. So I'm going to go ahead and put substitution property, only because we have used that in our previous paragraph over here by substitution. Alright, so then going back down, our final step is to subtract the measure of angle 2 from both sides, so we get the measure of angle 1 is equal to the measure of angle 3. So it's the same exact proof that we did on that previous slide, but this time it's now flowing, at flow proof, kind of using our deductive reasoning following a chain of events. Alright, so explain how you would find the measures of angle 1, 2, and 3. Remember, the word explain does not say simply solve for. You actually have to say how you do it. Alright, so first things first, the measure of angle 2, well, angle 2 is vertical of an angle 128 degrees. So isn't the measure of angle 2 simply 128 degrees? And we can state why because the vertical angle theorem. So I said here that the vertical angle theorem says that vertical angles are congruent. Alright, now to find the measure of angle 1, we need to look at this line right here. This right here is a linear pair. The measure of angle 1 plus 128 are supplementary, which means they have to add to 180 degrees. So since they add to 180 degrees, I can subtract 128 degrees from both sides, and I get the measure of angle 1 is equal to 52 degrees. Don't forget to write your explanation. Alright, so the linear pair theorem says that the angles here, angle 1 and 128, are supplementary. So by the subtraction property, we can solve for the measure of angle 1. Now, the measure of angle 3 is equal to the measure of angle 1 for the same reason. The vertical angle theorem says that vertical angles are congruent. Therefore, the measure of angle 3 has to be 52 degrees. Alright, here we are going to prove the common segment theorem. You have a 2-column here. We are going to use a 2-column to organize our thoughts and then put it into the paragraph proof. Alright, so what you see here is that I'm given AB is equal to CD in length. What we are trying to prove is that the length of AC and the length of BD are the same. Alright, so first off, AB equals CD. Well, that was given to us, so we're going to write given. We also know that BC equals BC. Why am I saying this? Okay, well, take a look. AC has a part called BC in it, and BD has a portion of it is BC as well. So we need to show by the reflexive property. Remember, I told you that this was sounding like, why would you ever need to say that something is equal to itself? Here's your first case why. BC equals BC by the reflexive property. They both share BC. Now I know that AB plus BC is equal to BC plus CD. How did I do that? Basically what I'm doing is I am adding BC to the original equation that we started with. So this is going to be the addition property. Now I'm allowed to add it to both sides because I've already shown that BC is congruent to itself. I have to add the same to the left that I do to the right. So now what I'm showing here is that AB plus BC equals AC. AB plus BC equals AC. Well, that is our segment addition postulate. And that BC plus CD equals BD. That's the same reason, the segment addition postulate. So I've already shown that AB plus BC and BC plus CD are the same. Therefore, I can say that AC plus BD is the same. So I would say either substitution or transitive property would work here. Alright, so basically what we're going to do here is we're going to change this. This is a nice, neat organization, but this time put it in a paragraph format. So what I'd like for you to do, here you have some space. You're going to start out with your given. It is given that AB equals CD. And by the reflexive property, we know that BC equals BC. Go ahead and try to finish this up and see how you can do. Take each statement and reason and include it in your paragraph. Alright, so as you can see here, I've finished writing this. By the addition property, AB plus BC equals BC plus CD. By the segment addition postulate, AB plus BC equals AC, and BC plus CD equals BD. So in conclusion, AC plus BD, AC equals BD by the substitution property, or you could say the transitive property. Whichever you put here, you need to make sure is the same in the previous one. So I'm going to go change this to the substitution property just to make sure they are the same. I kind of feel like substitution property would be better here because we are substituting BC plus CD in here, and then we're using the transitive property. But I'm not going to quibble over that. You can take your pick. So there we are back again at our finished paragraph proof. Alright, so I'm not sure how 2A got left off, but let's talk about it. It says, a student writes the equation in step 3 of the proof as AB plus BC equals CD plus BC. So instead of writing it AB plus BC equals BC plus CD, they put the BC, they switched it here. So it looks like this. Alright, and it says explain why the right side of the equation is equivalent to the right side of the equation in the proof. Okay, well we can switch these back and forth, and that is a certain property, okay? And that is the commutative property. The commutative property of addition. You should use your property table as a reference for that. Alright, 2B. It says the student claims that PR equals QS by the common segment theorem. Do you agree or disagree? This is actually not true. It's only going to be true if we know that PQ is congruent to RS. So write your explanation there. Alright, so here we are given a 2-column proof, and I want you to change it into a flow proof. Give it a shot and check back with your answers. Alright, so as you can see here, I have the 2-column proof at the top of my page, and I've begun my flow proof. Notice that for each statement they have their own bubbles, and for each reasoning I wrote in blue directly under the bubble. So what we have here is that angle 1 and angle 4 are supplementary, angle 2 and angle 3 are supplementary. So the reason for this is linear pair. That was given to us in statement 1 and reason 1. And then given to me is that angle 4 is congruent to angle 3, so that's given. What I can say from this is since angle 4 is congruent to angle 3, then I know that angle 1 and angle 2 have to be congruent. That's the congruent supplements theorem. And then last but not least, we have that the measure of angle 1 equals the measure of angle 2. It's no longer okay to just say angle 1 is congruent to angle 2. You actually have to say the measure is congruent, and that's the definition of congruent angles. Alright, that is all we have for today.